Good morning, everyone. I'm Prajanya. Today, I'm going to present my project on I2C serial protocol. It implements using a FSM model, and the designs consist of I2C master FSM and I2C memory slave FSM and 128 into 8-bit memory. So, so this is the model overview. Mm, uh, before looking to the FSM, we should understand the important signals used for the module. Clock as a system clock that drives FSM, and reset, active high reset, and WR selects write or read operation. Address, 7-bit memory address, D in data to be written, data hard. Uh, Data obtained during the read indicates the completion, uh, and these are the input output declaration in the code, where inputs are clock, reset, write or read, control, address, d in dr, output done. So and This is the FSM 12 state. In our module, we will be considering the 12 state FSM diagram, where uh, and the complete communication process is divided into different states. Each state performs a specific operation. Uh, uh, The state consists of ideal start, send address, acknowledgement one, send data, acknowledgement two, read data, complete address, get address, send acknowledgement, get the data, uh, send acknowledgement two. This is the FSM state for both master and slave separately, where the I'll be explaining it in each state, and this is the FSM state declaration in the code. We have used enum for uh, state declaration, and 12 states which are used are declared. First state, ideal state. Uh, uh, where it on it resets it resets the counter, and SCL, SDA, and SCA, SDL are resetted to the one condition, and uh, then it after resetting, then it moves to the start state, where start state SCL is resetted to the uh, ACL is resetted to 0, and SDA resetted to 0, ACL remains 1. Uh, and next it moves to the send address. Their module shifts 8-bit address, and read or write 1 bit at a time. The counter increment each clock until all 8 bits are counted for, while count increments 8. Once a count bits are counted, reset to the count 0, then a transaction for a acknowledgement address. This is a bit timing counter, not shift register. Address register was already latched in ideal. uh, Sir, one నిమిషం uh, the purpose to say the send address information. For I2C, the address information contains 7-bit slave memory and 1-bit read or write information. So they have declared 7-bit count is equal to and the counter keeps tracking the 8 bits being transferred. And next moves to get acknowledgement state, where it receives and checks the acknowledgement after sending the address. This where This state is important for making a decision point, where WR equals 1, which which uh, declares it should perform a write operation. If W is equals to 0, which declares it has to perform a read operation. uh, and then it moves to the next state, that is send data, where the this state is used only during a write operation, the sending a 8-bit data that needs to be stored in the memory. The FSM transfers the 8-bit data. uh, the counter resets to 0 and advances to the acknowledgement data. uh, then this state purpose is to receive and check the acknowledgement for the written data. If after 8-bit data has been transferred, the memory can now be stored the data and select the at the selected address, and then it moves to the read operation. Uh, read. The read path uses four states after the first address acknowledgement, that is uh, get address, get address and send acknowledgement. The first phase of read operation latches target address to be read and responds to the acknowledgement of a master. uh, this purpose is to send an acknowledgement after receiving the address, and the controller indicates that the address has been successfully received. Then it proceeds to get the stored data. Uh, I get data. The next state is get data and send acknowledgement. The 8-bit data that are the 8-bit data that selected in the memory location, the FSM retrieves and places it to the appropriate data register output. And the send acknowledgement, after receiving the acknowledgement, the controller indicates that the read data operation has been handled. Then it finally transmits directly to the complete state, where this indicates the completion or complete transition is finished. So data unconditionally returned, and after completion it returns to the ideal state, as ideal state is declared as a default following the next cycle. And this is the master FSM uh, of uh, mm, of the code. And this is the slave FSM, where the assign SDA, which is over here, which is uh, bolded. It is a important slave as the received data is declared in the output in the temporal. Conclusion: the I2C protocol provides the simple and efficiency method for serial communication. The design implements an I2C style master FSM and memory slave FSM. At 128 into 8-bit memory is used for storing and retrieving the data. The FSM divides the communication into well-defined states, uh, such as start to complete. Both read and write operations are supported. Overall, the project demonstrates how protocol communicates and operate and the operations. Thank you.